Another test that we can do for series is called the limit comparison test. The idea behind this test is we don't necessarily know what each of the two series do, but we want to look at the long term. So we're going to suppose that we have two series here. So we'll have from k equals 1 to infinity of a sub k, and then we're also going to have the series from k equals 1 to infinity of b sub k. It's really important that you know what one of these series does. You don't have to know what both of them do, but you need to know what one of them does. Then what you're going to do is you're going to look at the limit as n approaches infinity of a sub n over b sub n. So I'm looking at the terms of the first divided by the terms of the second. If that equals a number, so not 0 and not infinity, then the two series behave the same way. That's why it's really important for you to know that one of them either diverges or converges, because I'm going to use that to compare it to and then decide does it converge or diverge. So the limit comparison test is in the future, so long term, this is long term in the future, if the ratio is a number, then they both behave the same way. So let's look at a couple here. The first one I'm going to look at is the series from k equals 1 to infinity of 1 over the square root of k minus 3. Now that's not a geometric series. The terms are going to 0, so I can't say that it diverges because of the terms test. But this does kind of look like a p-series. It looks kind of like the p-series of k equals 1 to infinity of 1 over the square root of k. Because it looks like that, I'm going to use the limit comparison test to see what happens. And I already know that this one diverges. The p there is 1/2, which is less than 1. So let's look at the limit. We can use k's or n's, it doesn't really matter. As k approaches infinity, of 1 over the square root of k minus 3 divided by 1 over the square root of k. So it was the terms of my first series divided by the terms of my second. Just doing some algebra, I'm going to flip the bottom and multiply straight across. So that's going to give me the square root of k on the top, and then the square root of k minus 3 on the bottom. And since we're looking at this as it approaches infinity, you only have to look at the highest powered terms. So this is the limit as k approaches infinity of square root of k over square root of k, which is 1. So since I got the same number, I got a number that was not infinity, was not 0, that means that both of these series behave the same way. And because 1 over square root of k diverges, that means that our original series also diverges. So the idea behind this test is we're comparing it to something that we know. And you know stuff about geometric and you know stuff about p-series. So compare it to something that you know, look at the limit. If it's equal to a number, then they both behave the same way. Now let's look at the series from k equals 1 to infinity of the square root of k over k plus 4. We can't use the terms test. I don't really want to integrate that, so I don't want to use an integral test. It's definitely not geometric. So I want to think, does this look like some sort of series that we know about? Keeping in mind that we're going to be looking at limits. So if I'm looking at limits, I'm only going to be looking at highest powered terms. So I'm going to probably reduce this down to the square root of k over k, which is 1 over the square root of k. So I think what I want to compare it to, the series of 1 over square root of k, which again we know diverges. The p there is 1/2. So let's compare. I'll have the limit as k approaches infinity of the terms of my first series divided by the terms of the other series. Now I'm dividing by a fraction, so I'm going to flip that second one and multiply straight across. So I'll get the square root of k over k plus 4 times the square root of k. But the square root of k times the square root of k, that's just k. So I get k over k plus 4. And for the same reasoning as last time, k over k is just 1. So I did the limit comparison. I figured out that I do get a number, got the number 1. So they both behave the same way. And because 1 over square root of k diverges, I know that our original one also diverges. Let's do one more of these. How about the series from k equals 1 to infinity of 8 over k to the 8th plus 2? I can't use the terms test to say this diverges, so I gotta do something else. I definitely don't want to integrate that. It's not geometric. So let's try to use a limit comparison. So what does this look like? Well, to me it looks like 1 over k to the 8th. Looks an awful lot like that, and I know this one converges because my p there is 8, which is greater than 1. So let me do my limit comparison test with 1 over k to the 8th. So I'll get 8 over k to the 8th plus 2 terms of my first divided by the terms of my second. I'm going to flip the second fraction, multiply straight across, so I'll get 8 k to the 8th over k to the 8th plus 2. And now since we're looking at infinity, this 2 doesn't make a difference. I'll just get rid of that. And I think my limit is 8, which is a number, which means that both of these converge. So the limit comparison test, it's meant to show you, do two series behave the same way in the long term? If you get a number in the limit comparison, then that means they do behave the same way. If you don't get a number, then you need to do something else. Use some other test.